Hello everyone, welcome to the channel. I put together this simple setup to test some ideas and see if they work and to prove a point, I guess. The basic idea was to find a way to have different surfaces with different absorption properties. In this video, I'll go through the setup, explain what I did, and show how it works. When you're working with Phoenix liquid simulation and have water pouring out of an emitter, the liquid slides over any surface it hits and keeps moving until it leaves the simulation grid. In the dynamics rollout, there's a wetting checkbox that's off by default. If you turn it on, Phoenix creates a separate group of particles where the liquid touches the geometry. These are called wet map particles, and they stick to the geometry even if it moves or changes shape. The liquid will still slide over the surface, but it'll leave trails of these wet map particles behind. You can use these for shading, like blending dry and wet versions of the material so it looks wet in the render. When wetting is on, a few other options become available. One is the sticky liquid parameter, which makes the liquid interact with the wet map particles and tries to glue the liquid to them. For this to work, you need a bit of liquid viscosity. But we're not covering the sticky liquid parameter in this video. Maybe another time. We're also skipping the drying time parameter. This just controls how long the particles last, set in seconds. The default is pretty high, so you can usually leave it as is without worrying about particles disappearing. What we're focusing on is the consume liquid option. If you set it to 1 and run the simulation again, each liquid particle that creates a wet map particle will be deleted. It's like the liquid is being absorbed by the surface, leaving a wet spot. The cool part is that you don't have to set the consumed liquid to 1. It can be a lower number, meaning some of the liquid gets absorbed, while the rest keeps sliding over the surface, creating new wet map particles until it runs out. This is a simple but effective system, and most of the time, it's all you need to create realistic, believable interactions between the liquid and the geometry. Sometimes the default wetting system just isn't enough. For instance, if you have a very porous surface like sand and want the sand to look wet, the water would still seep between the grains and disappear. This also happens with concrete, which is very porous and keeps absorbing water even when it's already wet, but to a much lesser degree. Phoenix's wetting system, however, stops absorbing liquid once the wet map particles are generated. And that's totally fine. It's designed that way. Imagine a riverbed made of sand or a beach scene with waves crashing on the shore. You don't want your water to just keep vanishing, right? However, there are these special cases sometimes where you do want that. And even though the default wetting and absorption system doesn't cover it, Phoenix has other tools to help you achieve it. One of these tools is the particle tuner. This might sound complicated, but it really isn't. Tuners are a great way to control your simulations, and they're super easy to use, so bear with me, please. First, create a particle tuner and open the dialog window. Set it so that if the distance to your object is less than, let's say, 2 voxels, whenever a particle is within the 2 voxels distance, will be deleted. This tuner targets the liquid particles, so those are the ones affected. But hold on, that's not quite right. If we do it this way, the liquid will never reach the surface because it'll get deleted too soon. We need some delay. There's no built-in delay for particles deletion, so instead of deleting them right away, let's change some of their properties instead. You can tweak the size or speed, but let's choose one of the properties we're not planning to use for something else, like one of the color channels, for instance. Let's choose the blue channel. Before we forget, let's quickly go to the output rollout and enable particle RGB output. Not the grid RGB, but the particle RGB. When you do that, make sure that liquid is selected in the dropdown, and what you see below are the channels for this particular group. And while we're at it, switch to the wet map group and enable particle age so the age of those particles gets exported into the cache files. We might need it later. All right, back to the tuner. We'll increase the amount of blue by, say, 0.1 on each simulation step, where 0 is black and 1 is blue. But hold on, how do we know the birth color of the particle is black? Well, we don't. So go into the source, enable RGB emission and set it to black. Alternatively, go into the dynamics rollout and set the default RGB to black. This sets all the liquid from any source in the scene unless they are expressly defined to use some other color. That way, you don't have to worry about each individual source if you have more than one in a more complicated setup. Now we know the liquid particles are spawned colored in black. When they come within 2 voxels of the surface, The blue channel value will gradually increase by zero point 0.1 on each simulation step. The thing is, you might tweak the simulation and change the number of steps. If you set the steps to 5, the change happens in 2 frames. If you increase the steps to 10, it happens in just 1 frame, and you might have to constantly readjust this incremental step. That is the reason why I prefer using the other option, the Set To option. Say, I want to set the value to 1. There's a build-up time here that is defined in seconds. This way, the channel value will go from 0 to 1, and it will always take the exact same amount of time, no matter how many substeps you decide to use in the end. I work in 25 FPS. I used to work for a lot of television productions in the past, and here in Europe we use PAL. That's what I'm used to. So in my case, 0.2 seconds is 5 frames. You can adjust the timing later while you tweak your simulation. It really depends on how large the radius where the change starts is, how fast your liquid is moving, and so on. Let's start a new simulation and see if this is working. Now when the particles come within the 2 voxel radius, they start to change color. You may notice that the particles do not appear entirely black in the viewport. That's just a preview thing. You can go into the preview rollout, and here you can see that Phoenix is set to show the particles darker or brighter, depending on their speed. You can set that parameter to no scaling, and now you can see the particles' exact colors. This is very useful when working with colors. You can always switch it back if you want. Right, so everything works as expected. And now we need something to take care of those blue particles. We need a second tuner. Create one, or just shift drag the existing one, and make a copy. By the way, I like keeping the tuners on a separate layer, with all the extra entities that they create. That keeps the layout view nice and tidy. Anyway, so in this second tuner, the one that will be deleting the particles, right? Select Delete Particles over here, and we have to change the condition. Open the Edit Condition dialog, and in the first part of the comparison, select the Channel option. Switch it to RGB blue. Click on the yellow line here on top. Change the comparison method to is equal to. Select the second part of the expression, select number, and set it to 1. Or, just to be safe, you can set it to 0.9 and change the comparison to is greater than. It should work in both cases, but I don't know. Maybe I prefer the second one. I used to do this for the temperature channel, and the temperature is affected by the cooling parameter, so it may never reach the desired value. Or maybe it can go beyond it, and setting an exact number might not be the smartest choice. For colors, the only thing that can alter the color value is the RGB diffusion parameter. It'll blend whatever colors you have. Since we work with a single channel, I don't believe it matters that much. You can leave it like this, or set it to 0. You decide. Anyway, let's start another sim and see what we've got. Right, so the water starts pouring. The particles are black at first. When they reach the surface, they start changing color. And when they are blue enough, the second tuner kills them. Okay, let's quickly recap the current situation. We have a tuner that checks if the particles are close to the surface, and if they are, it paints them in blue. That happens gradually in a few frames. A second tuner deletes the particles when they become blue. That's it, as simple as that. They are left with enough time to live on the surface and create the wet map, or perhaps splash back up and form some tendrils, or produce some splash particles if they are set to do that, and so on. But then, when they spend enough time on the ground, or close to it, depending on how many voxels you have set in the distance parameter of the first tuner, they will disappear as if the surface absorbed them, despite whether or not the surface is wet or dry. As I said, it is simple but effective. You can now combine this with the integrated absorption system. Put some small amount of liquid absorption here in the dynamics rollout. Make some of the liquid disappear instantly when it touches the dry surface. The tuners will take care of the rest. All right, that's great. But let's complicate things a little bit, shall we? Let's introduce a second object. I have this box here on the ground. I'll just go ahead and unhide it. Now we need to measure the distance to this object as well. But you can't add a list of objects that the tuner measures the distance to. You can only choose one. Sure, you can have another tuner with the same conditions, but with the second object selected. But what if you have 3 or 5 or 100 objects? Tuners are great, but they still need to perform their checks on each step, and that adds to your simulation time. Having a few is fine, but keep in mind that they slow things down. Even if it is only by a small amount, adding more and more of them can make things less optimized. So let's think for a second and try to come up with some other solution. Here, in the tuner options, We have other things to which we can measure the distance to, for example, other particle groups. And what other particle groups do we have? That's right, wet map particles. Choosing the distance to particle option and adding the word wet map into the field will check if there are any particles from that particular group within the specified radius. If I leave the radius as it is at the moment, 2 voxels, this means that the condition will be true for any liquid particle that occupies the same voxel as the wet map particle, or is one layer above it. You can perform that check for more than one group. Just add it to the list and separate the entries with commas. You can also check for the same group and detect if a particle is isolated from the others. You can remove it, slow it down, or perform any other action on it. All right, let's check if this works. And it works beautifully. Now, you can add as many objects as you want. And as long as they are solid objects and have the wetting option enabled inside the Phoenix object properties, which, by the way, is the default state, they will be covered by the wet map. And this will trigger the true condition inside the tuner. Now, we can tackle the final challenge. How can the tuner be active on some surfaces but not others? To do that, we'll need an extra condition. Select the yellow line again, and here on the right, you can see a button that says this and a new comparison. Press it and it will keep the existing one, but it will add an extra one underneath. Choosing the AND method means that both of these conditions need to be true for the tuner to affect the liquid. If you choose OR, this means that either one of the conditions could be true to trigger the effect. But we need both, so AND is our choice. So let's select this extra condition and see what we have here. Again, you can check for specific channel values. You can check for distance to particles, to objects. Oh dang, I just realized that you can probably add extra comparisons and add more than one object without countless tuners. But anyway, let's not get distracted. Right, so here, we can also test for intensity value of a texture. And we can have a black and white texture acting as a mask, defining where the tuner will be triggered. Choose texture intensity. And now let's think about what sort of data we can pull out of this scene and turn it into a black and white mask. This part is where I hit a bit of a roadblock. At first I thought, well, that's easy. Just use a vertex color. Paint the more dense objects in black so the tuner won't affect the liquid that is close to them. Paint the more porous surfaces in white. Get a vertex color map. And stick it in here. Right? Well, not exactly. I tried it and it didn't work. I scratched my head for a while, wondering why it wasn't working. Then I remembered something quite important. This texture needs to be a 3D texture, and the vertex paint map simply isn't. So I scratched my head for a bit more, and I thought, well, maybe a V-ray distance texture will do the trick. And it did. Let me open a blank scene and show you how to set it up. I'll just create a couple of spheres, make them non-renderable. Create a plane. Open the material editor, create a V-ray distance texture. Add the 2 spheres to the list. Get a V-ray material so that we can apply it to the plane and see what we're doing. Plug it into the diffuse, maybe into the self-illumination as well, since we don't have any lights right now and perhaps we won't see anything. Apply the material to the plane. Open the frame buffer and start the IPR. With the default settings, we have a black color near the surfaces and a white color far from them. We can select the inside separate checkbox and the inside solid. That will fill the inside of the objects with black. You can stick a color correction here and play with the contrast if you want. You can adjust the distance, just don't make it smaller than your voxel size. It's probably not a good idea. And here's our mask. We can apply this in our tuner's texture intensity slot. You can always add additional objects. Let's create a teapot here just to test it out. Simply add it to the distance list. And that's it. There's one other way to get black and white values in 3D space. It is way more complicated, but I'm going to show it to you anyway. It is a good Phoenix exercise, and you might find it useful. But just in case you're already bored and just want me to get to the point, I'll create a chapter here in the YouTube video so you can skip this part. Okay, you're still watching, so let's do this quickly. Create a Phoenix fire and smoke grid. Make sure it covers your entire scene. Go into the output rollout. We don't need smoke. We don't need temperature. We only need RGB. Create a Phoenix source and add the objects that you need to mask. Again, we don't need the temperature or the smoke. We only need the RGB. Set it to white. Go into the simulation rollout and uncheck the timeline checkboxes for both the start and the end. Set the end time to 0, same as the start time. We're going to simulate just one single frame. Press start. And it is done. Make sure that this one frame stays throughout the entire timeline. In the input rollout, simply check load nearest if missing. There it is. I simulated frame 0. My timeline starts at 1. That's how I set my 3ds Max defaults. But it doesn't matter. That one frame will stay loaded the entire time. Or just select cache index and set it to 0. Cache index means frame number. So once again, frame 0 will load no matter which frame you drag your time slider to. In the preview rollout, the RGB is shown by default, and we can see the white color emitted by our objects. The rest of it is black. You can see the black if you adjust the ranges over here. Okay, maybe the default surface force emission mode is not the most appropriate. You can select the Phoenix source and change it to volume brush. That way the emission will happen inside of the objects and not only on the surface. Change this, and Phoenix will ask you if you wanted to change the objects to non-solid for you. You can agree to that. Press the start button one more time. Right? There it is. Open the material editor again. Add Phoenix grid texture. Do not check the render time only. This mask should be visible during the simulation, not just at render time. Set the channel to grid RGB. Tiling mode single is fine. The linear sampler is fine. Make sure that the coordinates are set to world XYZ. Pick the simulator from which the data will be read. Plug this into the diffuse and the self-illumination. And start an IPR. There's the mask, except that it is inverted. An output node can be added to invert the values to what we need. And now we have the same thing as before. The edges are a bit jagged, but this shouldn't be a problem. Besides, you can always increase the resolution and resimulate. Done. Takes about a second. Right, as I said, that's an overcomplicated and over-engineered way of doing a simple thing. But I wanted to show it to you because who knows, you might need it sometime. Also, if you're not using V-Ray and you don't have the distance texture, this might be an alternative method to use the colors in some other renderer. They just need to support the Phoenix grid texture. Or, if they do not, you can still write that one frame in OpenVDB format out of Phoenix instead of the native AUR. The black and white values are going to be embedded inside the voxels, so in theory, you should be able to use some volume grid loader available in whatever other renderer you are using, and use its alternative to a volume grid texture. Okay, no more distractions. Let's get back to our scene. Here's the distance texture with our concrete blocks added to the list. It's a list, so you can add as many as you want. Plug it into the texture slot of the tuner. Set the condition to is greater than. Put a value of, I don't know, 0.5 maybe, meaning a middle gray color, meaning not black. Start the sim. And there you have it. The tuner works, but only where the texture isn't black. Let me see if I can make it a bit more obvious. I'll rotate the object slightly. Scale this one a bit. And yeah, it looks like everything is in order. Seems like the liquid hit the bottom of the container down here. Let me just scale down this box a bit. Cool, it's working. It's updating. Everything seems fine to me. Actually, you know what? Let's take a look at the final scene, the one that this render came from. I think it is this one, 006. Yeah, that's the one. Here in the assets layer, I have the render geometry. Here's the floor and the two tiles. They are just boxes with a chamfer modifier and turbo smooth. I didn't use these for the simulation. The floor is a plane object that doesn't have any thickness. And this is something that you need to avoid in simulation. But this one is only for rendering, so it doesn't matter. In the PHX layer, I keep all Phoenix-related stuff. There's a sublayer called colliders. And here, there are copies of the three objects. They are collapsed to polys, and I keep them displayed as boxes. Also, this copy of the floor has a thickness. In fact, if I select the simulator and go into the scene interaction rollout, you can see that I added the three other objects to the exclude list. That way, if I accidentally leave them visible when I start the simulation, they won't interfere and mess it up. There's a particle layer where I move the particle containers just to get it out of the way. And here are the tuners. Let's take a look at them. The first one checks if a liquid particle is within 2 voxels radius from a wet map particle, and if the mask intensity isn't 0. If that's the case, it sets the blue channel to 1 with a delay of 2 frames. The second one deletes the liquid if the blue channel of the particle is above 0.9. And there's a third one that I added as a final tweak. It just sets the speed of the liquid to 0 after 1 frame when the particle hits the sand. This just creates some friction, and I thought that it might add some extra realism. But that's not part of the custom absorption system. You can delete it, and it will still work. This geosphere is the emitter. It is animated to move from one side to the other. It has some animated noise applied. There's the Phoenix source with the geosphere added as an emitter object. And finally, the simulation itself. In the material editor, I have the distance texture for the mask, with a distance set to 0.5, and the 2 tiles added to the list. Remember, those are the black spots in the mask. And there's a color correction to increase the contrast. Exactly what we did a moment ago. Okay, that's pretty much it. I showed you how the default consume liquid parameter works, and why it works that way, and why it is perfect for most of the times. I showed you how to modify it if you need to, combining it and modifying the liquid's lifespan with tuners. I showed you how to mask it. I got a little distracted along the way, but I hope you'll forgive me for that. I'm not going to talk about how to blend wet and dry materials in this video. I'm just going to put the material graph here on screen so you can take a peek. If you want me to cover this in a separate video, write in the comments. Let me know if you would like that. Take care and goodbye.